Okay, so we are live now. So right now we are going to solve one question which is from AlgoEpert called the Fibonacci series.
Yes.
Okay, so let's start without any further delay. So here we have to do one thing. We have to solve this question with in JavaScript. So language is JavaScript right now, which we are using.
Mm-hmm.
Okay, this is the question. The Fibonacci series is defined as follows. The first number of the sequence is 0, the second number is 1, and the nth number is some n minus 1. Okay, so it
So,
means if we have number like 5, then the Fibonacci series would be the first number would be first, second number would be second. Normal list till 5 is 1, 2, 3, 4, 5, and the numbers of Fibonacci series would be the first number is 1, second number would be 2 minus 1, 2 minus the first index, and the third would be 3 minus 2, and the
I
fourth.
think it will start from 0 and then it will go to the first index that will be 1, and that's how it increases.
0, 1, 0 will be
Then,
considered as a Fibonacci series. Yes, you're right, Nikhil. My bad. So the 0 index would be 0, the first index would be 1, and it
yeah.
start from 2 second index minus first index. So 2 minus 1, 3 minus 2, 4 minus 3, 5 minus 4. So the sequence will become 0, 0, 1, 1. I think something is.
So you have to subtract the position, like the index values, but not the index.
Okay. So if you are going to subtract the index value, not the index.
Mm-hmm.
So in this, the index value is, so the index value is 1 or 2, right? So if we have to give a list till 5 number, so the index value would be 1, 2, 3, 4.
Index start from 0, 1, 2, 3, 4, and the value start from 0, 1. That is fixed. Fibonacci series first value is 0 and the second value is 1. And from
The
here we
first,
start counting, like putting the logic of adding last two numbers. From third, was second, third, just from third index, we start applying the logic.
so second minus 1, 3 minus 2. So 3
The
minus 2
same.
would be 3 minus 2 would be 1, 4 minus 3 would be 1. So the difference
No,
will be always 1.
no, that's what I'm saying. It's not about index, but it's about index values. And that is the result of past two numbers. So if 0, 1 is your first two index, then third index will be 1 plus 0, that's 1. So third index value will be also 1. And then fourth index will be 1 plus 1, that will be 2. So that's how it increases progressively.
The nth number is the sum of n minus 1 and n minus 2.
Yeah, and
Okay,
minus 2.
got it. So this logic is completely wrong. And if these are the index values, then the list would be, the first would be 0, the second would be 1, and the third value would be 3, which is 2 plus 1, which is 2 plus 1, and the fourth value would be 2 plus 3. Sorry, yeah. And the next value would be 3 plus 4. Right, Nikhil?
I still think we need some modifications because the third index value of third index is still not correct.
0, 1, 2, 3, 4.
Let's do one thing to make it more simpler and understandable. Let's put at index of 2 and index of 1.
Index of 2, and index of 1. So index of 2 is, if I
So
say index,
index of n is index of n. The value of index of 1 n is value of index of n minus 1 and value of index of n minus 2. Matlab, that's the last two numbers that we have to count and add them and put it at the position of n.
Okay, so the nth value would be n minus 1, n minus 2, sum of this,
It's the
these
sum
two
of these two.
sum of these two values.
Yeah. And initial two values are always fixed, that are 0 and 1.
Okay, so the initial values are fixed 0, 1. The next value would be n minus 1, which is 2 minus 1 is 1, and n minus 2 is 0, so 1 minus 0. It would be 1 minus 0, which is 1. And for the third index, the value is 3 minus 1 and 3 minus 2. So 2 plus 1 is 3.
Yes.
3 minus 1 plus bracket of 3 minus 2. That would be our third number. We have to do this thing in a recursive order.
Yes. So we have to keep doing this thing again and again till
Till
index.
we have to find the number. Okay, so it will become like 0, 1, 1, 2, and so on.
Yes.
This is the four value of our first 4 value of our Fibonacci series. So here we go. So if we have to do this with the help of recursion, what we can do, when we know we have 2 value fixed, we can just write something like this. If our list of the value is 0, we'll directly return that there is only one value which will have of 0. And
Yeah.
if
So, like before we do recursion, let's have a basic understanding of what recursion is. So, someone is not familiar with it can also do so.
okay,
Like he will also get familiar with recursion.
sure.
Yeah.
So Nikhil, explain what is recursion here.
Now, it would be better if you can do this.
Okay. So basically,
I
recursion is
know
a
because
way.
you know better. So.
Uh, sure about it, but still, okay, I'll try. So recursion is a way in that we call a function in a repetitive order, and we use that function, like we start that function from the end state, and we'll go from end to the first state. So if I say I have to say number from 1 to 5, and if I'm saying 1, 2, 3, 4, 5, the recursion will see the first number is 5. What is the condition which we have to check for 5, and then 4, then 3, then 2, then 1.
Not absolutely right. So, same thing. That's what we are trying to approach and get this thing done.
Okay, so I think recursion is the best way to do this. Normally, people do Fibonacci by ordinary ways, but we are not going to do this. We are just making this stream useful for everyone. So
Yeah.
let's do this thing. So if I have the value is 0, we'll return that 0 because there is no value present in that number. So if someone is given, we have to find the value of 1. So the n is 1, which means we have to find Fibonacci series with 1 index. So it will directly not 1.
Not one,
And
but yeah.
so right now
Yes.
we are doing JavaScript, and in JavaScript we have to compare it with triple equal to's. It will find compare the types and the values on as well. So if the value is 1, we'll return what will return 1
We will return
because
one.
for 1.
Yeah. So
Okay,
these are the conditions that we already know. Then when
no.
Fibonacci series is there, the index 0 is always 0 and index 1 is always 1. So these are our exit conditions that are, like you can say, a building basic block that is required for a recursion to be completed. If we don't have any exit condition, then recursion will keep on going till the infinite and you will never get the result. So we need an exit condition for a recursion to work properly.
So now we have handled the first, like the end state condition, which is 0 and 1, because in recursion we start from the end and we complete our execution from the beginning, which is 1 or 2, 1 or 2 in value at the index of 0 or 1. So if we take the example of 6, if the value is n of 6, we have to check for the index value of 2, 3, 4, 5, 6. which we can use by this recursion, and it is very very simple. If I use recursion, I'll reuse that function and I'll just pass that n minus 1 plus n plus 1. So what I'm doing here, what if the value is 2 is passing from this function, it will go directly on this thing, and
I
this
think it
function.
needs some tweak because n minus 1 and n plus 1 is like
Okay,
being the
and
sum of one previous one. So I think, yeah.
sorry, I wrote it mistakenly.
Oh.
N plus 1. So we will return the n minus 1 and n minus 2. So
Mhm.
when the value is 2, it will return 1 to this function and 0 to this function. So when we pass 1, it will go inside this and it will return 1.
Yeah.
So if I run this code, it passed only one test case. Nice.
Okay. We will iterate and fix this.
It has passed only one test case. So
Mhm.
what we have done wrong, Nikhil, here?
Let me have a look.
Expected
Mhm.
5, the answer is 8. Okay, we are adding some more values more than required. 4
And then,
zeros.
mhm. Sum of last two numbers.
Get
What's n? Is it number or is it index? Is it number,
it is
right?
a number. It is a number. So if number
So
is
if number is 0,
mhm,
if this number is 0,
it will return 0. It will exit the condition.
so let's add one more condition here in line number 7 as
Mhm.
or n is
For
equals to
2.
2, then we'll also return 1.
Okay, so we'll try this when n equals to
Yeah.
2 as well. We'll return this. Okay, 1.
Something is wrong.
Yes.
So we have a number as 2. So 2 will return this as 1. That's correct.
For n is equals to 2, n is equals to 2, that means we have to, the list would be 0, 1, 1. For 0, 1, 1, it will return 1. But n is equals to 2, how would it return 0, 1, 1, 1? Okay, it should return only the sum.
No, it's gonna return us the series or for the purpose of
Nth
the
Fibonacci
question.
number, right? We have to
Mm-hmm.
return the nth Fibonacci number.
And the last one, I guess.
Last one, yes.
That's fine. The sum of last two numbers.
Okay. Then how can we do this?
The number is 0. Okay, if number is, if you can control Z and do one thing,
Mhm.
if number is, I think, less than 1, less than or
Then we
equal
are,
to, then we should
yeah,
return 0. Zero or 0 or 1.
1. It should be 1. For the case of 1, the value of the last one value is 1. The value of last Fibonacci number is 1.
Now, I'm considering the case when we are at second index.
Okay.
So we cannot do n minus 2.
N minus 2. At second index, the value will be 1, right? The
Second
first
index
index
does
is
not
0.
have 1. But if that position, if we do n minus 1, we have
Mhm.
n minus 1, but we don't have n minus 2.
Let me do one thing. If we can do this, so still
Number is 1. Okay.
Let me check some hints, which we have done this earlier.
Yeah. Go ahead.
So the value is n is equals to 2, we're returning this.
For one possible, we are returning as 0.
0.
And why we did
Okay.
that? Do you have any?
Because if the value is 1, we are checking only the first value. According to the normal question, the value first value is 0, second value is 1. Second value is not at the third index. We are mistaking it with the index, but the first value is 0. So if n is equals to 0 or n is equals to 1, then we are doing this. For n is equals to 2, that means we are checking at the second value, and for this second value, we are just returning our Fibonacci series. So it will just return us the last value of that list.